Hey everybody, it's me, Lady Ada. Thank you to the kind puppets for introducing me. So I'm actually broadcasting from Manhattan. So we're here in the Empire State doing this thing, taking a break from the unending updates and Cuomo live casts. So let's get right into it. I've got a presentation that I'm going to screen share, and then if you have questions, pop them into the chat, and then I won't be able to get to them while I'm doing the presentation, but at the end, ask anything, engineering questions of any sort. Okay, so let me do this thing. Okay, cool. All right, so yes, we're here. We're socially distanced, but we're doing this thing. I've been to a lot of maker fairs. I've been to like the first maker fair, which was in um, San Francisco in the Bay Area, and then I've been a bunch of times to the ones in New York, which were super fun. So it's cool to see that we're still doing this. Like we're not gonna stop making just because maybe we can't go to some fairground, eat paella. Um, so this presentation is going to be um, not as much about electronics, because I feel like we do a lot of live shows with electronics you can watch. We do show and tells, and we do live casts constantly. So if you want to learn about Arduino or Raspberry Pi, go there. But I thought I'd chat about what we did, Adafruit as a company, as a community, when we were in March and April, kind of in the thick of it, and how we used our maker skills and technologies to help the city and help the state. And I think we're all in that situation. I think a lot of people in the fall, in the spring, early spring, were thinking, how can I help? How can I make things better? Because things are pretty bad. And I really hope that we don't end up in the same situation in the next few months. But the only thing we know for sure is we don't know. So being prepared, being ready for what may happen, and that's something that makers are really good at. As makers, we take things and we modify them and we hack them, and we learn and we share, and it's all about making things that maybe don't exist yet. And that's something that actually started happening here in the city. um, so that's me with PPEs. That's a post-COVID photo. Some of these photos will be pre-COVID and some will be post. And you'll know because people are close together. So to the bottom right, there's our factory building. So we're in Soho. The factory building is in the old printing district in Manhattan. It's a beautiful building, and we're one of probably the only electronics manufacturer in the city for sure. There might be some on Long Island, but I think in Manhattan we're probably the only one. And we have about 50,000 square feet, and we have like 2 floors where we do all of our shipping and manufacturing and tutorials and videos. Like it all happens there. Some of it now is happening remotely and safely, but we're still open operational. And this is basically what we did in March and April, while also keeping the business going, right? Because I think that's another important thing. We want to make sure that we can pay all of our employees, almost all of whom are New Yorkers. So, I think people remember that, in February and March, everything was really hectic and there was a lot of adversity. We didn't know what was going on. We didn't know what we had to do. There was not enough equipment. There was a lot of fear. There was a lot of sirens. It was just really, really gruesome. It was really horrible. I hope we never have to go through that again. But that adversity can reveal character. Like when things are going to shit, that's when you can step up and help out. And I think what's cool is to see how many people in the maker community immediately stepped up and said, "Here's what I know. Here's how I can help," and self-organizing. I think a lot of us are aware that we're heading into the fall. This is day 231, so we've been at this for 231 days. I think during the summer, we had some good, nice days. Like I saw people in cafes outside. I had people with walktails, and seeing businesses reopen safely and staying around. I think that's been a really positive experience. I think that should carry us through the fall and winter as we head into the next 100 days, which I think are going to be challenging. But again, that challenge can reveal character. And throughout this entire time, it's not just me. Like, I'm giving this presentation, but I'm speaking on behalf of like the 100+ people on the Adafruit team, and like everybody pitched in, and it was so awesome to see that folks who were crafty were like, I'm going to do tutorials on how to sew cotton masks when you couldn't buy masks. The only way to get them was to sew them. People who are like, I want to do tutorials. I'm going to do more live streams because I think the community needs that. We have a weekly show and tell, and historically now it's a half an hour, but so many people from the community wanted to have something to do on a Wednesday in March, April, and even May and June, that we extended our show and tell to an hour just so I had more time for people to come by and have this sense of community, because folks who are used to going to hacker spaces and maker spaces couldn't do that. So instead, having an online community, like, we have the internet, so let's use it. And of course, the customers. We've gotten a lot of notes. Somebody even sent a note to us this week and said, hey, I'm my wife is going through chemotherapy, and she's immunocompromised, and so we're extra careful. We really have to be careful about where we go and what we do, because we can't get sick, because she's already sick, and it could be really devastating to our family. And this person said, thank you so much for doing the stuff you do, being safe, showing how you're operating safely, so that I can confidently order electronics, build stuff at home, keep doing my job, keep doing my hobbies, without worrying about could I get sick from a package, or are these people not taking proper precautions. So I think that care that has gotten us to this 231st day, we just have to keep doing it for the next 100 days. And these are the Adafruit people I was talking about. This is, of course, a pre-COVID photo. But there's people here who do shipping, that they do kitting. There's people who are on the manufacturing equipment. There's people who write guides and edit videos. There's people here who do every kind of job, from bookkeeping, to helping with facilities, and they're all part of what makes us happen. We work together. Some people working remotely, and some people are working on site. I go in every night on site, and I do some electronics at home, and then I go in and I do electronics at night when people aren't there. So socially distanced that way. I hope one day we'll be able to take another photo like this, maybe soon. So, basically what happened is, we had started reducing our occupancy in February, because around January, and folks can even watch videos from early mid-January, we were noticing that some of our PCB manufacturers or component suppliers, or people who made stuff in China, were saying, hey, our factories are shut down, like we're not able to function, or we have to have a reduced schedule. And so we were starting to hear from our partners in China about basically the COVID infection happening. One of our suppliers is actually literally in the center of Wuhan, and so they got really devastated. But hearing from them was really helpful, because as the wave started in New York, they actually were like, do you need masks? Do you need PPE? Here's some information. Here's what we did. But basically in February and March, as we started to see New York start to tick up, we reduced our occupancy to 50%. People who could work from home just go home, and then 25% using staggered shifts, staggered schedules, and keeping people separated. So we have multiple floors, just made sure that everybody was really far apart, and offered PPE and hand sanitizer. But we basically, I think in early March, it was March 20th, 15th, we got an email, phone calls from the EDC, the Empire Development Committee. I actually can never remember what EDC stands for, but basically they're kind of like this glue that tries to connect all the businesses that are working in New York to try to solve problems. So their problem was, we really, really needed face shields. They needed thousands of face shields and immediately, because they couldn't get them. Again, there were no shipments coming out of China, and any PPE was, it was completely bought up. It was impossible to get. And they're like, we just desperately need face shields. We understand you can't make, N95 masks. They asked us, but could you make these plastic face shields? And this was actually while we were starting to go into sort of shutdown mode. We had been planning on doing this 3-month shutdown. But, we still had folks who were thinking about how to solve this problem, how to make these face shields. So you can even see a demonstration here of me wearing, well, a photo of me wearing this face shield. People in the maker community started chit-chatting. They were like, could we 3D print them? Do we use foam? What kind of plastic should we use? What kind of elastic should we use? And there was like this very fast iterative process where a lot of different maker spaces, and this design I think is actually from a Wisconsin maker space. A lot of people came up with what's the least expensive, fastest way to manufacture thousands and thousands of face shields, and how to do it using materials that you could get from McMaster Carr or your local clothing or fabric store. So thankfully a makerspace actually hooked us up. Make It Labs contacted us and said, we saw, we had a little bit of plastic, so we were able to make some of these face shields with like the foam and the elastics. So we had enough components to make a couple hundred of them, and to get them to medical professionals in the New York City area. But we actually were running out of the plastic. That's the reel of material that's right behind me. This kind of flexible, clear, durable plastic that's easy to laser cut. And we had a laser cutter. So that was like, you don't have to like cut by hand. We had this maker tool, right? Laser cutters are like an awesome maker tool that people use to make enclosures or to cut wood pieces that snap together. And so we got, the Make It Labs put us in touch with this company called Novalex. And Novalex, if you look it up, they actually make like those clear plastic salad containers that like you get when you go to the bodega, and like you open the container and you like put your salad in, you close it, and then they weigh it. So that thing, they like press it out of this plastic and they like fold plastic, and they're like, oh yeah, we have like a roll of this plastic because we just use tons and tons of this stuff. But because stores are closed, we're not selling as much, so we actually have an extra reel of this material. And so we kind of did this like quick work with the makerspace Novalex and got a bunch of the plastic into Manhattan. We have a freight elevator, and that's what allowed us to get this plastic in. The makerspace was like, we literally have no way of getting this like 600, 700 pound thing into our makerspace. It's just too big. But because we had a freight elevator, we could have a freight truck bring it in, put it on the loading dock, and then you can see we've got the little forklifty thingy. You put it into the elevator and bring it up, and then we can cut it to be turned into face shields. Let's be on top of it. It's big. It was a really big piece of plastic, and we went through about I think a third of it, and then it turned out that by then it was actually really easy to get face shields. We were going through it as quickly as possible, and we made a couple thousand face shields, and then the plastic supplier that were nearby to us said, okay, we've got plastic now, we can make face shields. So we were able to fill that gap of a few weeks until factories were able to tool up. And me wearing it, testing out the initial design. So we actually had a team of folks who came in, they're employees, but they volunteered to come in. Some people were like, hey, I'm not ready to come into work yet. I'm going to continue working at home. But there's some people who said, no, I'll come in, I'll make face shields. And so you can see we had a little mini assembly line. We retooled our factory. We had the space. We had 2 laser cutters going. One person was cutting out the plastic sheet. And then another person would, remove the foam glue strip thing and put it on, and then another person would cut the elastic and staple it down, and then we would dunk it in an antiseptic to clean it off, and then we would individually bag them so that they knew that there was no cross contamination, all while wearing PPE and doing the best we could at the time. Like we didn't know what was required of us to stay safe. This was kind of back when people were like, well, washing hands, wearing masks, maybe, like we don't really know, like try not to be close to each other. So, people were biking in, we got a bike rack outside of our spot, and, we cranked through these, and we made a couple thousand of them. You can see a couple boxes, and we shipped them as quickly as possible both to the EDC, and then after the EDC said we're good, then we actually started shipping them to individual doctors and nurses that contacted us, because word got out. People were like, they're like, there's these like makers in New York and they've got face shields, and the doctors and nurses were like, we don't have enough. And instead of going through like the EDC request process, they kind of like circumvented it. And they just emailed us directly and said, can you help us out and get us some? So we would, because we had the capability to do shipping and packaging, like we had all this stuff ready. It's just instead of shipping, electronic components, only we were now shipping, face shields and other PPE. There's some more photos. So yeah, so we also had some 3D printers going. We have a 3D printing farm, with a remote staff that does 3D printing tutorials. Noah and Pedro, they do an awesome video show every Wednesday called 3D Hangouts, but they also have like a farm of like 3D printers, right? They have like the Ultimakers and like the Maker Bots and like the, mono prices and whatever. And so they just start cranking out this design. This is also an interesting thing. There's this, iterative design process for making these snap-on 3D print face shield like tops, and then you would hole punch the acrylic. Again, it would still be, the PETG. You would laser cut it or hand cut it and then hole punch it, and then you would like hook it on. So we had a couple of both. We would have the laser cutter going, we'd do the foaming, we'd also have the 3D printer. So we had a lot of options. And at the time you would see like news clips of doctors and nurses in hospitals or healthcare workers, and you'd see them actually wearing these 3D printed face shields. So actually they were used. They made a difference, which I think is important. I think that sometimes, there's this feeling of like, oh, makers are so amateur. Would anybody actually use it? But they really did. They used it, and they used it a lot. And we got a lot of emails and thank yous from medical care workers who were like, thanks, this is really helped. Or the people who they worked adjacent to the medical, industry, like they were transporting people, from hospital to care facility. And they're like, well, I'm not like a registered nurse, so I don't have PPE. So this is the only way I could get protection, because I'm in a car with people and I want to make sure I don't get them sick. So the next thing that came up is after we like kind of did our best to solve this like no face shields available anywhere in the city issue, and basically got the EDC going. And it was also the Navy Yard also had groups of manufacturing companies that were helping making face shields. So the next step was, can we make ventilators? I can't tell you how many people would call me on the phone and say, do you like have a ventilator design, like ready to go? And I'm like, I don't. This is not something I've ever designed before. It's not easy to design. We could do it, but we have to work together as a team. We have to have a lot of people with a lot of different expertise. It's not like a face shield where somebody with scissors can cut it out and like staple it and like you're done. A ventilator, you have to test it. You have to have engineers look at it. You have to have people who've done medical devices work on it. You want to make sure that if you're going to make something like that, we can do it, but we want to do it right. So the EDC was working with a company in, sorry, I can't remember their name off the top of my head, but the factory in Brooklyn at the Navy Yard, and they were interested in making ventilators. There were actually a couple different designs. MIT was working with one, and then some New York people were working with the MIT design, and there was one in Italy. So there's actually quite a few open source or like DIY low-cost ventilators that people were designing. And the goal was to make them with off-the-shelf components. So off-the-shelf components for ventilators doesn't mean stuff that you get necessarily at Home Depot, but it does mean you need stuff like sensors, right? You need pressure sensors, you need humidity sensors, you need temperature sensors, you need flow rate sensors. And these are all things that Adafruit was doing anyways. Like we actually stock a lot of the sensors that end up being used in ventilator designed. Not everything, but enough that was like helpful for people. And so we, so the next request we got from the EDC was, okay, can you like supply like, and actually it was interesting. The thing that people needed the most was not even the sensors, oh, they needed them. It was like displays. They really wanted TFTs and touch screens and like the microcontrollers and all that stuff to be able to control the interface for the ventilators, because a lot of times they would be able to get a flow rate sensor from like Sensorion, or they would get the air valve is not very complicated. It was the UI that was actually quite challenging. And so we ended up chatting with a lot of different groups. I think easily a dozen, 20 groups, all trying to figure out how to actually make a really good user interface. That was actually the challenge a lot of them had, was how to make it so it was usable, so it would alert nursing staff if something went wrong, or it would verify like nothing. You know what I mean? It's like, it's easy to make a ventilator that can go wrong. How do you make it so it doesn't go wrong? That's the challenge. So we were, manufacturing, like pre-COVID photo. This is Michelle and Vance. So we were running parts of the machine. People were like, I need 1,000 displays. And we're like, well, we can actually churn out 1,000 displays. Like, we have the raw components. And even if we weren't able to get anything out of Wuhan, we had a lot of LCDs and TFTs and buttons that we could start to cobble together. And then folks were like, well, could you make us a custom thing? And I was like, yeah, we can do that when you get to that point. But I would recommend, I recommended people just use off-the-shelf parts. It just would like, if you're not making 100,000 of these ventilators, it doesn't matter whether or not it's custom, right? The cost wasn't the issue, it was speed. So we actually had to do like same day delivery in New York to some of the teams in Brooklyn that were working on electronics. So this is one, this is one of the ventilators. This is a rendering of a ventilator. And you can see, the box is quite simple. It's just like this kind of off-the-shelf steel box. And then there's like a touchscreen TFT. And there's just like a bunch of knobs on the side. And this is what's inside of it. So it's like if you like pulled the box open. So you can see on the left and the right, there are the valve, input valves. So these air valves are quite simple. They just open or close. And then you have like a pressurized air source that can push air in and out. And then you just have valves to control the pressure and the airflow. But then you have to have the sensors that detect, because you have to like do this. Like, I learned a lot about ventilators. You have to detect like when somebody's starting to take a breath, so you don't push air into someone while they're trying to exhale, or like you don't over push while they're like, you have to kind of do this like slow thing and then come down. Anyways, I don't know why I know about ventilators, but we do all this research to try to get people the right sensors. So this is a Feather board. This is our kind of plug and play electronics board. This one I think is a ESP32 based one. And again, I recommend people, don't make make as little custom stuff as you want. So the green shape in the center is a custom PCB, and then they plugged the Feather into it. And that way they didn't have to worry about like that part of the design. They could focus just on, this was, I think, the relay controls. You can see that the wires, the blue and pink wires coming out. Those are the relay controls that go into the air valves. Also, at this time, we were getting a lot of people who wanted Bluetooth capable chips. That's because folks were starting to think about how to do contact tracing with Bluetooth. I think now we actually have an app, right? Like as of like last week, which is great. Download it, install it. But at the time, people were like, well, can we use just like raw Bluetooth devices? Because this was before Apple had permitted people to do, they didn't add like these little changes that allowed people to do Bluetooth range detection. One of the side effects of good privacy policy is that when you have a Bluetooth device, there's this MAC address, right? There's this unique identifier, which you can kind of sniff in the air, just like Ethernet. You can see packets going by with a certain MAC address because you have to know where the packets are being routed to. But what's interesting about Bluetooth is Apple does this thing where they randomize it. So you can't track somebody through their MAC address. Like if you see the same MAC address twice, it's actually not the same person. They're two random numbers. And that actually made it hard to do contact tracing because there was no way to know if someone you were seeing, like if you were detecting them from their Bluetooth MAC address, you couldn't use that again, right? You had to have an app that would have some way to emit data that could then be like continuously tracked. Anyways, it turns out that the Apple ended up working with governments to make that possible. But at the early time, and also folks were trying to think, how can we design contact tracing with Bluetooth that did not require a phone, maybe low cost contact tracing. And actually, Bunny Wang and Sean Cross ended up making hardware, I think, along with the Singapore government, called SIML. And the idea was to make a very simple, low cost, near disposable, basically low enough cost that you could give it away to people, Bluetooth tracker that had didn't have this MAC address recycling issue. So we started just like, but like this was like some news thing, and somebody was like, "Oh yeah, you're on CBS Philly," and it says like Adafruit on it. I don't know what they were working on here, but it was probably something like that. Yeah, so we were manufacturing, and this is post-COVID. You can see we live together, so it's okay for us to be that close. But we were doing, same day delivery. We would, folks would say, "Hey, we need like 25 LCDs. We need 25 pressure sensors. We're trying to get our prototype going." Because when you're designing a ventilator, this is for the ventilator project in Brooklyn. When you're designing a ventilator, you have to do this thing called the pig test. And like, it's exactly what you think it is. Like, they take a pig, right? And it's like, poor pig. It's just like, it's probably thinking like, I'm gonna have a really great day. So they knock out this pig. They put an EKG on the pig, and then they hook up the ventilator to it. And then they make sure that the pig doesn't like die or have a heart attack. And then, yeah, this is what the pig does all day. It's just tough job for the pig. But they have to, the FDA was starting to do like very, very fast track testing. Like, normally to like get signed up to do like this pig test, this porcine test would take, months, right? You'd have to get in line, you have to wait. But the FDA was like, it's actually kind of cool. They were like, we want to get people thinking, even we don't know if this is going to work out, but we want to help people who are interested in making these low cost and quick run ventilators. And so there was a lot of like, okay, we're signed up for the pig test on Tuesday. We have to like make another bunch, and then have to do revisions and tweak things, and then go back to this like pig, which is just like pigging out. So we do a lot of same day deliveries. So this is us getting a box ready before I think we had like an Uber come by or a Lyft, and we'd put the box in the back, and they would drive off to Brooklyn. Yeah, there you go. Me with the box. So it was traffic was very light at that time, so they got there fast. Okay, so that was like March and April, which was really hectic. I mean, I was like, I think, we were on video calls and email threads, and just every day was like a different group of people who was like, here's a different medical thing that I'm trying to design, and trying to hook up people who had all these skills. What's cool about the maker community is there's a lot of hobbyists, of people who are like, I'm retired and I'm just hanging out. But when they weren't retired or during their day jobs, they're making the same kind of electronics or doing the same kind of design that is industry, right? They're industry workers. And so given that they were working from home anyways, it was a lot easier to get in touch with people and say, hey, you are like the best stepper motor driver designer I know. Can you help us out with this stepper motor gear down circuit design for like an airbag ventilator? And they're like, oh yeah, sure, send it over and I'll take a look. And everyone was really willing to chip in, and that was really heartening. So now this was okay. So now we're like transitioning to like May, June. By this time, New York was starting to kind of come down off this peak, and then the goal was, well, how can we reopen safe and smart? And I think we're still doing that like every day. So we had so many of our factory partners in China they're actually kind of freaking out for us, because like they don't ship a lot of stuff to New York, and New York was in the news a lot at the time. And so they contacted us and said, hey, do you need PPE? Do you need like masks and gloves and face shields and stuff? And even though it was very, very hard to get stuff into the country, I mean, everything was being stopped in customs, everything, which was fine. I mean, it wants to be inspected. And there was a lot of, unfortunately, a lot of fraud that happened as well. But our suppliers are like, well, we can hook you up with PPE, and they would like send us small boxes that we could then redistribute. And then we eventually got, good suppliers, and was able to get enough PPE that we started distributing it to local businesses. So, for some folks, people who are watching this, we probably know how to use the internet. You're like, you want to buy something, you can, figure out how to go to Amazon, or you can go to, like GearBest or whatever, and order non-contact temperature sensors or something. But there was a pizzeria nearby, and the owner was like, he's like, I don't really use the internet. I have no idea how to get PPE. Like, if it's not available at the Costco, I can't get it. And so we had the Hudson Coalition, right? It's not enough that there's like New York City, and then there's like Soho. There was like Hudson Square Business Cooperative, right? Like this little group of people that were just for the Hudson Square area. And we had a mailing list, and small businesses that needed stuff could say like, hey, I really need, I'm trying to reopen up my restaurant. I'm trying to reopen up my business. What are you doing? How are you controlling like elevator usage? And so there's a lot of communication there. We also ended up on the Mayor's Council for Restarting the Economy. And like for the first one, there's a mayor, and there's me, and it was a coalition. It was actually cool. It was people from Chinatown, from Harlem, from Brooklyn, from Queens, from Red Hook, from Staten Island, from all over, doing all sorts of things. Of people who would like make furniture, and there are a lot of restaurant owners and like bookstore owners, and like there was like 50 people all chatting and sharing ideas, and then sharing them with the aides to the city to say, here's what we need, and here's what would work. And so some of the things that came out of that were the fast track restaurant outdoor eating. So how like it was really fast, how every restaurant is like, we're just going to go build like outdoor seating. So what this council did was work with the city and say, you can't make it, so we need to have inspections. There has to be like it needs to, like, yes, if people are abusing it, enforce, the laws against them, but don't make us have to get an inspection to open. Let us, follow, give us guidelines, and they gave the guidelines of how much space you need and what kind of parking spots you can use and how you can arrange the outdoor seating. And then let us take care of it. Trust the business owners, the restaurant owners, the cafe owners, take care of their customers and their staff. And I think that actually worked out really well. And that's why we were able to see some restaurant businesses reopen. We also worked on, at the time, there was a lot of chat about whether, Google and Apple would make a contact tracer app, but we made one that was kind of like we actually took like a geocaching kind of app idea, where it didn't do like contact Bluetooth tracing, but it just tracked where you were. And we thought that would be at least a good start while we were waiting for this Bluetooth protocol thing to happen. It's interesting how everything like ended up hinging on this like weird privacy policy that Apple had. But now there's proper Bluetooth contact tracing apps. But at the time, we wanted to do something for our own team. So for like all of the summer, we offered this for free to our employees and our customers, and it's on the App Store. We also had a group of people, Adafruit. We actually picked the people who were the most vocal about saying, here's what I want Adafruit to do for me to be able to come back, right? We it's like, it wasn't just up to me and Phil. We actually had people who worked in facilities, and they would help come up with what were the protocols for how we're going to open safely, how are we going to, what distances are we going to have, how are we going to keep the windows open but keep people comfortable. We're going to run the air conditioner, so what kind of filters do we have, and like all the little details that you have to check, because this virus is like, it's so sneaky, right? And if you make like one mistake, it'll get you. So you have to be so careful. And one of the cool things that we did was surface testing. So we got like a surface testing kit, and we tested once a month. We swab like the fridge handle, right? Like the places where people are touching the most, like the elevator buttons. And one time we actually found on one outer doorknob of the most popular door, like the main door, we found some traces of dead COVID virus. So this is why it's important that even, people are like, oh, there was this I don't say a desire, but like, folks are like, they don't want to wear masks at work. You don't want to wear gloves. And folks are like, well, can I like not wear masks and gloves at work? What if, I'm not near anybody? It's, no, you have to, right? Because even though you may think, this seems like a safe place and nobody at Adafruit even tested positive, there's always a risk, right? So why risk it? But you can check out our Open Safely document. Especially if you have a maker space, it's going to be very similar. How do we open that maker space or hacker space? And now we're still open. We're still doing stuff. We are still doing our split schedules. We still have reduced occupancy, but we're making and we're shipping. We have about 100 people in New York City, working with people's schedules. We had night shifts, we had weekend shifts. We had people. Our factory's pretty large. It actually wasn't too hard to keep people separate. Folks who could work remotely as much as they can. And we're taking this opportunity to do other stuff too, right? Like we're not gonna, we did face shields, we did ventilator work, and we're ready to go back into it. But we also wanted to stick to what we're good at. And I think that's something that's important. I am not an expert at ventilator design. I will help, but it's just that's actually not my skill set. What I can do is make the microcontrollers, the dev boards, the tutorials that help people make those things. That's my skill set. I think it's important to do what you do best, explore, but also do what you do best. So we took the opportunity to certify all our open source hardware. So we did 400. It was awesome. We pushed them past 1,000. It was every day there was 50. We just kept submitting them. We finally had time because we had people working from home, a lot more people working remotely, and so we were able to do a couple projects that had been kind of sitting, waiting, or we were interested in, but just couldn't find the time. I was well, this is a perfect time to go down our to-do list, skip all the ones that required us to be physically on site, and do projects that we could do remotely. So we did a buy one, give one for Black Girls Code, where people could purchase Circuit Playground Express, our development board for learning electronics. They'd get one shipped to their home, and then we would ship one free to Black Girls Code, and they would distribute it to girls and students working at home to try to have remote learning opportunities. And what's cool is all the software and tutorials and videos that we've done have always been online. So it wasn't the only way to learn Adafruit stuff is by in-person workshops. It's never been true. We designed lots more feather boards. We did much more work on CircuitPython. There's no way to know what electronics I'm designing now that might be useful in the future for other crises that may occur. When I designed the Feather ESP32, I didn't think, I hope a group of Europeans are going to use this in an open source ventilator design. I had no idea. You don't know what people are going to do with their technology, but if you share and you publish and you keep doing it, it will be perfect for somebody. So what we're doing now is, we're kind of doing the same thing we've always done, right? We're back and we're operational. Again, with reduced schedules, I go in at night, and there's some people who work late, some people work early, some people work 4 days with extended shifts, etc. We've basically been back since May, so we're back in business. A lot more people are, of course, doing remote learning or more remote teaching, which is great because we have a learning system and tutorials for people around the world. We've always had that, so it's we didn't have to put all of our learning online. We're doing more videos for sure. I think people who are makers are, they're going to be at home more. They're going to have all these electronic parts. They're probably going to say, hey, this is a good time for me to learn a new skill or to brush up on a skill, to learn a new technology, because time passes anyways, right? We're going to be going through this until March. You might as well pick up some skills on the way through. It's easy to be deflated, but if you're just look, time's going to pass. It's going to suck sometimes, but let me have some fun. Let me have some educational experience on the way. I think that's a good idea. So yeah, this is what we did. We're keeping on making. We've been making face shields, making electronics, making educational stuff for people learning at home. I think don't stop, and don't feel ever just because you're making something that's silly that it isn't maybe essential. I saw a lot of people who were into knitting or crafting or sewing or quilting. They had their moment. It was just I'm going to make cotton masks cotton mask covers for nurses, and there was like this huge community effort to do that, and people made thousands and thousands of cotton face coverings, and that's something that they could only do because they had a disgustingly large collection of fabric at home that they'd been intending to use one day, and they finally got an opportunity to use it. So it all worked out in the end. All right, so that's my I'm going to stop this sharing thing because I think I'm done. Okay, cool. All right, so I'm back. And I think I got like, what, 5 minutes? So if like people have QA time, let's see, I have to learn how to use this thing. I see attendees, I see panelists. One thing I will say I'm not good at is I have to find where the chat is. I don't see anything. But maybe if the organizers can pop questions over if there are any. Q&A. I don't see any open questions. All right. Well, it was good to see everybody here. Thanks. Thanks for coming by. There's like 20 attendees. All right. Well, thanks everybody. We're gonna still do our weekly show and tells. So if you want to come by and ask questions about electronics, or you want to show off a project, come by Wednesday at 7:30 Eastern time. We're on youtube.com/Adafruit. And we also have live streams on Wednesdays. We have 3D Hangouts. We've got Make Code Minute, which is great for beginners or teachers. We've got deep dives with Scott. That's Thursdays or Fridays, and that's like kind of like more hardcore engineering that goes on for a couple hours. We have a question. Can you share info about trading you offer? I'm not sure what kind of trading. We don't like trade goods usually. But what we do have is an open source community of people who share stuff together. So, you know, for example, we're doing CircuitPython right now. We're developing this kind of easy to program way to use microcontrollers. And we have a lot of other businesses that are really interested in being part of that community. And what they'll do is they'll say like, hey, I want to use the software. I will help like contribute like this library or this tutorial. And if you can help me with something else, then be like, you know, we'll code contribute back and forth. Like, can, you know, like, can you add support for this flash chip or this LED? And we're like, yeah, we can do that. And then they'll fix some bugs. And so that's kind of how we do trading, which is how makers do trades. Okay. What Mike Sensi asked, what's the difference between designing a maker focused board and a medical grade one? A lot of it is testing requirements. There are requirements for example, like, you know, static ESD protection. That's like the most basic one, right? Like you have to have protection against faults. You have to have interlocks. You have to have a broad range of testing on the device. There's just going to be a lot more checks for things because it's not like a maker device. You know, like I see people do live demos with their maker device and it doesn't work and they just like hit the reset button. Okay, but if somebody is like on a ventilator, they're not going to be able to reach up and press the reset button when something goes wrong. So a lot of it isn't on like the core functionality, which is the same. It's on all the things that you have to do around that device to make sure it's done safely and correctly. And that's what's hard because makers often assume, and there's no reason not to, that there's like a straight line between what they want to do and how to accomplish it, right? They want something to connect to the internet, get some data and display it on a TFT. Okay, well that works as long as your Wi-Fi is working right. You don't have disconnections. Your TFT is easy to read. You don't have a spike of RF noise. You don't have someone who has just been on a carpet all day and they touch one of your USB connectors and actually, you know, they put like 4,000 volts through it. So that is the stuff that you have to take care of when you do medical grade. But luckily, there are people who do this sort of thing for a living, and you should use those resources, right? I wouldn't recommend folks DIY that because you're going to have to go through a skilled engineer in the end anyways. And there is published documentation. Like I read the documentation for alerts, right? There for medical devices, there's been analysis on what kind of alerts work best, like how to get people's attention without causing like alertness fatigue, like something's beeping all the time, you just ignore it. So that kind of skill, it's just like there's so many things and you don't know what they are unless you know what they are. And so that's why it's not a good idea to try to like fake that. You want to get somebody who's done it because they're like, oh, I know exactly the checklist to go down and make sure that I hit all these things. Okay, I think did I get all the questions? I don't know if somebody's speaking, I can't hear them. Okay, well, it's 1:45, so my time's up. But yeah, if you want to ask more questions, come by show and tell at 7:30. Oh wait, we have one. How do you make Adafruit a viable business in Manhattan? I don't understand the economics. It works out fine because electronics is a very small and precision thing that you manufacture. So the things that you think are expensive in Manhattan are actually not the things that dominate your costs. Like it's more about design and getting the right people and the right skills and doing documentation tutorials and videos. And that's something that people in New York are really good at. We're very creative people. All right. So thanks, everybody. And thank you, Empire Maker Faire. It was great to see you. And keep watching.